This is Sara Hojjatie, lab section M04 for the first at-home lab video report. The observation was a car moving in traffic, and the assumption was that the net force is equal to 0 because the velocity of the car is constant. So as soon as the car tire comes into the picture, I set the origin to be in the center of the tire, right here. So at the first frame, the tire is in view, begins at the origin, and I set the positive x direction to be to the right because it is in the direction of the motion of the car. So the video starts right as the red car enters the frame, and I calibrated the diameter of the wheel to be 0.60 meters, which was found online, to set the length scale. The time per frame is 1/30th of a second, and the length of the total video is 0.70 seconds. And so, as you can see, the car is moving in the positive x direction, and the last frame is right after the front wheel goes out of view. The mass of the car was found online to be 1,814.37 kilograms. However, it was not needed because the forces in this situation cancel out and are 0. The initial position of the wheel was 0 because the origin was placed in the center of the wheel at the beginning of the video, and the initial velocity was found by dividing the change in position by the change in time over the entire course of the video. So the data right here, these values are placed in the data right here. These values right there. And so then we run the program and see the ball moves in the positive x direction. And this graph is for the motion of the car. And comparing this predicted motion to the actual graph of the motion, which are the blue and the predicted in red, you can see that there was the predicted data and the actual data were very, very close. There was a small variation to the predicted data, which could have been caused by human error when using the tracker software. Additionally, friction and air resistance were not taken into account because they were assumed to be negligible, which could have caused some error as well. The what if question asks what effect changing the location of the origin would have on the data. If the origin is placed more to the right of the initial position, for example, the wheel would begin from a negative position, causing the initial position to be negative. This would cause the graph to shift to the left, but it would not affect the slope of the graph because this movement of the origin does not affect the velocity. So this graph would just be shifted to the left to start at a negative position. So the what does it mean refers to the statement that the net force is equal to 0 because the velocity of the car is constant. It wants to see, can the pushes and the pulls be broken down and listed? And indeed they can. Assuming that this cube represents the car, there is a downward force of gravity pushing down the negative y direction and a normal force in the positive y direction. Also, there are the forces of air resistance and friction, which are in the negative x and positive x direction, which we have considered to be negligible. So the positive and the negative y directions cancel out. We have considered the negative x and positive x to be negligible, those forces. So altogether, these forces give a net force of 0.